right, everyone, we are back, and we are going to do our problem set 2 solutions. So, we're playing a game of chess, put all the pieces in a bag, mix them up. What's the probability I pull a pawn or a black piece? So, we're going to have to think about mutually exclusive and not mutually exclusive events. So, you can see here, pawns, we have 1, 2, 3, 4, 5, 6, 7, 8. So, there's 16 total pawns. 8 of them are white, 8 of them are black. I can pull a pawn that is simultaneously a pawn and a black piece. So those are not mutually exclusive events, meaning probability of A, B is going to be equal to probability of A plus probability of B minus the probability of A and B, the intersection. So probability that I pull a pawn will be 16. There's 16 pawns out of 32 total pieces. What's the probability I pull a black piece? 16 out of 32. What's the probability that I pull basically a pawn that is also black? It is going to be 8 out of 32. There you go. Or, excuse me, minus. So, that's our solution. So I have to subtract out that probability that it's simultaneously a pawn plus it's also a black piece. There you go. What's the probability that I pull a pawn or a rook? Now, those are not mutually exclusive events, so I'm just going to do probability of A plus probability of B. So, pawn, 16 out of 32. Rook, there are 1, 2, 3, 4 rooks. So, plus 4 out of 32. This is a 6. So, 20 out of 32. Great. Let me see if I can scratch this out. Excellent. All right. What's the probability to pull a bishop or a white piece? So bishops, there are 1, 2. So probability to pull a bishop, I have 1, 2, 3, 4. So the probability of that is 4 out of 32. A white piece is 16 out of 32. Minus, again, make sure, minus, I can pull a piece that is simultaneously white and a bishop, and that's going to be 2 out of 32. What about a king or a queen? King, there are only 2 out of 32 pieces, plus a queen, which is 2 out of 32. And that's it. Great. I have one of my research students pull a piece from the bag, and the next piece pulled is a knight. What's the probability that the first piece was also a knight? So this is a Bayes theorem. So we're going to have to look at, we're looking at the probability that I pulled a knight given a event occurred. So that's effectively what we're going to be looking at. We're going to use that Bayes theorem. So A is what? So let's see, or B, piece of 1, it could be, so basically it's about this first piece. So it could be a knight. It also could be N-I-G-H-T. It could be also a rook. It could be a bishop. What else? Bishop, king, B4, king, B5, queen, and then B6. It's going to be, there's only 6 types, right? 1, 2, 3, 4, 5, 6. Yep. B6 is going to be a pawn. A is, I pulled the knight. So, we need to look at what's the probability that I pull a knight? Well, there's 4 knights, so 4 out of 32. So we could look at each of those probabilities. So that's also going to be 4 out of 32. That's also going to be 4 out of 32. That's going to be 2 out of 32. That's going to be 2 out of 32. And then that's going to be 16 out of 32. So we all have our probability PB1. Now we need to look at what's the probability that I pull a knight A, given that the first piece was a knight. So there were 4 out of 32 knights. So if I pulled, what's the probability, given the first one was a knight, that I pull a knight? So that's going to be 3 out of 32. All of the rest of these, what's the probability that I pull a knight given the first piece was a rook? Well, that's just going to be 4 out of 32. Oh, excuse me. Not out of 32, out of 31 because we removed that piece. Same thing here. 4 out of 31 pieces left. And that'll be the same for all the rest of them. So we could actually go into Mathematica. I'm just going to say PB1 equals 4 out of 32. PB2 equals PB1. PB3 equals PB2. And then we have PB4 equals 2 out of 32. PB5 equals PB4. And PB6 equals 1/2. 1/2. Now we have PAB1 equals 3 divided by 31. And then the rest of them will be PAB2 equals 4 divided by 31. And then PAB3 equals PAB2. PAB4 equals PAB2. PAB5 equals PAB3, or 2. 2. And I need to change that to 5. And then PAB6 equals PAB2. There we go. So now we can do our Bayes theorem, which is going to be PB1 times PAB1 divided by the summation PAB1 times PB1 plus PAB2 times PB2 plus PAB3 times PB3 plus PAB4 times PB4 plus PAB5 times PB5 plus PAB6 times PB6. And 3 out of 31. That's it. Actually, let's make sure it's this over this. So, there we go. We solved and got our problem. Fantastic. What about simple bag? So now the next piece is pawn. What's the problem? Probability. So now let's say it's pawns. So let's just actually, the only thing that will switch is this. We're just going to call, the only thing that will change, we don't change our probabilities here. So PB6 is our one of interest. What's the probability that I pull a pawn given that the first piece was a knight? So that will be, and we'll call that, that's going to be 16 out of 31. That'll be 16 out of 31. And the rest of them will be 15 out of 31. So we're going to do that. PB6 over this. PB6, PAB6. Shift enter. And there you go. Pick another one. That's it. Fantastic. So we'll see you all next time. Have a good one. Bye.